Good morning, class. We are looking at Chapter 9, Sequences and Series. Here's Section 9.4, the Binomial Theorem. So we covered sequences and series, arithmetic sequence and series, geometric sequence and series, and now the Binomial Theorem, and the objective is to apply the Binomial Theorem. So we looked at series and summation notation. S sub n, the sum of a sub 1 plus a sub 2 all the way to a sub n, the first n terms of a sequence. Sigma is the Greek letter sigma and indicates a sum. The sigma notation, summation of a sub I going from 1 to n, means add the terms a sub I beginning with the first term and ending with the nth term. I is the index of summation. I is called the index of summation. A finite series S sub n goes from a sub 1 to a sub n, summation of a sub I going from 1 to n. S sub infinity, a sub 1 goes to a sub n, and n goes to infinity. So a sub I, summation of a sub I going from 1 to infinity. Summation properties, if a sub 1 and a sub 2 and a sub 3, all the way to a sub n, that's one sequence. B sub 1 to B sub n is the second one, or two sequences, and C is some number, a constant. For every positive integer n, we have the following properties. For example, the summation of C as I goes from 1 to n is n times C. Arithmetic sequence and series. An arithmetic sequence, each term after the first one is found by adding a fixed number called the common difference to the previous term, is an arithmetic sequence or arithmetic progression, such as a sub 1, a sub 1 plus d, and so on. The difference, also known as the distance d between consecutive terms, is constant, and the sequence can be defined by recursively a sub n plus 1 is a sub n plus d, explicitly a sub n equals a sub 1 plus n minus 1 times d. Example 1, add 4 you get 5, add 4 you get 9, add 4 you get 13. So this is the first term, a sub 1, and d is 4. The nth term is given by a sub n equals a sub 1 plus n minus 1 times d, and the sum of the first n terms is s sub n over 2, a sub 1 plus a sub n, or n sub 2, n over 2 times 2a sub 1 plus n minus 1 times d. And here's the synopsis of the whole page. A geometric sequence. So we are looking at geometric sequences and series. A geometric sequence or geometric progression is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number called the common ratio. Geometric sequence is in the form of a sub 1, comma, a sub 1 r, all the way to the general term a sub 1 r to the power of n minus 1, where each term is r times the previous one, can be defined recursively by a sub n plus 1 equals r times a sub n, explicitly by a sub n equals a sub 1 r to the power of n minus 1. And here's the synopsis of that. And the sum s sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. Needless to say, r can't be 1. If r happen to be between negative 1 and 1, s sub n, in essence, s sub infinity is a sub 1 over 1 minus r, because as n goes to infinity, this goes to 0. A number between negative 1 and 1, if you raise it to the power, ultimately it approaches 0. The binomial theorem, we're going to go with the counting theory for now. Independent events have the following definition. Two events are independent if neither influences the outcome of the other. Sequences of independent events can be counted using the fundamental principle of counting. We have a specific definition with numbers and formulas for this in statistics. Fundamental principle of counting. If n independent events occur with m1 ways for event 1 to occur, m sub 2 ways for event 2 to occur, so on and so forth, and m sub n ways for event n to occur. Then there are m sub 1 times m sub 2 all the way to m sub n different ways for all n event to occur. That's the fundamental principle of counting. Here's the first example. If there are 3 roads from Albany to Baker and 2 roads from Baker to Creswich, how many ways are there to travel from Albany to Creswich? What you're looking at is called a tree diagram. It has a lot of applications in stats and probability. So from Albany to Baker, we have a 1, 2, 3 different ways, 3 different roads. And we have 2 roads from Baker to Creswich. 2 roads. So how many ways are there to travel from Albany to Creswich? This is 1 way. This is the 2nd way, 3rd way, 4th, 5th, 6th, 3 times 2. For each of the 3 roads to Albany, there are 2 roads to Creswich. There are therefore 3 times 2, 6 different routes from Albany to Creswich. A restaurant offers a choice of 3 salads, 5 main dishes, and 2 desserts. Count the number of 3-course meals that can be selected. The first event can occur 3 ways. That means 3 different salads. The second event, that means main dishes, can occur in 5 ways. And the third event, meaning desserts, can happen in 2 ways. So multiply them out. 3 times 5, 15 times 2, there are 30 possible meals. The factorial symbol and binomial theorem. If n is larger than or equal to 0, is an integer. The factorial symbol n factorial is defined as follows. N factorial is n times n minus 1 times n minus 2, all the way to number 1, 3, 2, 1. 0 factorial and 1 factorial are both 1. We can, especially 0 factorial, they say by definition, but it's really by the combination definition. It can be proved. Now here's the combination definition. The way we write them, we can write them parentheses n comma r, c and r, or parentheses n at top or at the bottom. N factorial over r factorial times n minus r factorial. So we choose r from n, and order is not important. If we want to simplify this, we can write 12 all the way to 1, 10 all the way to 1, or because 12 is larger than 10, we keep this one and we write 12 factorial as 12 times 11 times 10 factorial. So the answer is 12 times 11, which is 130. The binomial theorem. We remember a plus b quantity squared is a squared plus 2ab plus b squared. We remember a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now the general, if it's x plus a to the power of n, this is combination of n0, by the way, combination of n0 is 1, x to the power of n plus combination of n1, a x to the power of n minus 1, all the way to the power, combination of n, and this is also 1, a to the power of n. This is the binomial theorem. Or you can write x plus a to the power of n is the summation as r goes from 0 to n, and you write the combination formula n factorial over r factorial times n minus r factorial, x to the power of n minus r, a to the power of r. These are the ones that I highly recommend you look at them. Combination of n choose 0 is equal to combination of n choose n, and it becomes 1. Combination of n choose 1 equals n. I want you to look at those, develop them using this formula. And combination of n choosing r is the same as combination of n choosing n minus r. In other words, if these two numbers, they add up to n, then these two combinations are the same. You can try. So this is the synopsis of what we need to know. Let's elaborate on this. Evaluate 5 factorial and 7 factorial. Well, this means 5 times 4 all the way to 1. 20 and 6, the product is 120. 7 factorial, 7 times 6, 5 go down all the way to 1. And just for the sake of argument, since you have this one, you multiply it by 6 as well as 7, this number. You get 7 factorial, which is 5040. Now, of course, mostly it's done by technology. So if you want to go with the TI calculator, you use factorial. You enter the value of n first, and then press math, select probability, and select the factorial. So it looks like this. You press math, and then you move it to PRB, and you move it, in this case, is number 4. Of course, first you put 5, for example. Okay, math. And then this number 4. And for example, if you do 5 factorial, it calculates it for you at 120. Permutation of n elements taken r at a time. A permutation of n elements taken r at a time is one of the arrangements of r elements from a set of n elements. And the notation is PNR. If P parentheses n comma r, or PNR in this format, denotes the number of permutation of n elements taken r at a time, with r being less than or equal to n. R must be less than or equal to n. Then the permutation is n factorial over n minus r factorial. Note, order within the group of R objects is important. Order is important. So we have this formula. For instance, an ordering of 3 books selected from 5 books is a permutation. Of course, we are assuming 5 different books, 3 different books we pick. None of the books is being the same. There are 5 ways to select the first book, 4 ways to select the second book, and 3 ways to select the third book. Thus, the permutation of 5 3s 5 times 4 times 3 equals 60, or you can say P5 3, put it into this formula, becomes 5 factorial divided by 5 minus 3 which is 2 factorial. If you do the math, you end up with 60. Assume 8 people enter a swim competition. In how many ways could the gold, silver, and bronze prizes be awarded? Obviously, order matters. This is a permutation of 8 people taken 3 at a time. Note, order within the group is important. And that's the key. Order is important. It makes it a permutation of 8. Choose 3. N is 8, R is 3, which makes it 8 factorial over 8 minus 3 factorial. So the bottom is 5 factorial. There are 2 ways to handle it. I'm going to quickly show you. The top is 8 all the way to 1, 8 times 7, and so forth. 5 all the way to 1 multiplied. Or go back here. 5 is smaller than 8, so you keep the 5 as 5 factorial. And 8 is 8 times 7 times 6 times 5 factorial. So it's simply 8 times 7 times 6, 336 different ways. If we use a calculator, we enter the value of n, we press math, we select probability just like before, but this time we choose either NPR or NCR, in this case NPR, and then we put the value. So in this case, first we would put 8, then we put NPR, we find it, this is how we find it, and we would put 3. This is where NPR is found. So 8 NPR 3 gives you the same answer. Of course, as long as you can show this step and then you can use a calculator, because this shows the formula. Combination of n elements taken R at a time. A subset of items selected without regard to order is called a combination. A combination of n elements taken R at a time with R less than or equal to n is denoted by C and R, or n comma R, or C and R, and is sometimes read as n choose R, which is n factorial over R factorial times n minus R factorial. The most important thing, the most important difference between combination and permutation, order within the group of R objects, is not important. Example, how many different committees of 3 people can be chosen from a group of 8 people? See, it doesn't matter in what order we choose them. We just want 3 people. A committee is an unordered set, the arrangement of people, unordered set, or the arrangement of people. Therefore, order is not important. We just want 3 people. Combination. So with the combination formula, we have n, which is 8 factorial, over R, which is 3 factorial, n minus R, 8 minus 3 makes it 5 factorial. So we have 3 factorial and 5 factorial in the denominator in any order. Now, how do we simplify it? Again, here's the easy way. The largest number at the bottom is 5. So 5 factorial, if you keep, you write the 8 factorial as 8765 factorial, and 3 just to make sure is 3 times 2 times 1. And so here's how we simplify them. We know 5 factorial and 5 factorial cancel each other. We know 3 times 2 is the same as 6. So it's 8 times 7 or 56. And again, if you go with technology, go the same process. You first put n, and then you choose. Of course, we're going to choose NCR, and then 3, and we get 56. So as you recall, there was 336 different ways for permutation, and there are only 56 ways for combination. Why the difference? Order is important in the first case, permutation. Over here, order is not important. That's why it cuts the number. All right, so here's the formula. Let's quickly calculate those for 1. So we are going to go with this formula. 4 goes up here, 4 factorial, and then 1 factorial, 4 minus 1, or 3 factorial. Again, to simplify this, the bottom is 3 factorial. We know 1 factorial is 1. We're going to write 4 factorial as 4 times 3 factorial. The answer is 4. 5, 3. So the top is 5 factorial. The bottom is 3 factorial times 5 minus 3, or 2 factorial. Again, the top is 5 factorial. This one we keep. We make the top as 5 times 4 times 3 factorial. This is 2. These two cancel each other. These two give us 2 times 5 is 10. 7 and 5, we want to choose 5 out of 7. 7 choose 5. Combination, 7 factorial over 5 factorial times 2 factorial. So the 7 becomes 7 times 6 times 5 factorial. These two cancel each other. 6 divided by 2 is 3 times 7, 21. In other words, there's an easy way of doing this. A combination of 8 choose 0 as this format, where 0 factorial is 1, and you end up with 1. So these are useful formulas, and CN0, we looked at this example, we came up with 1. CNN, I highly recommend you try it. For example, C8, 8, C7, 7, and so forth, that becomes 1. CN1, for example, we looked at 4, 1, and we ended up with N of 4. Cn with N minus 1 is N, for example, C10, 9. If there's a difference of 1, you can try that. And two combinations, when the bottoms, they add up to N, they are identical. These are really useful combinations for the sake of the binomial theorem. It speeds up the process. Now, the binomial theorem. So the binomial expansion is as follows. X plus y to the power of 0, of course, is 1. We know this one is x plus y. We've discussed this one, x plus y squared, and we've discussed this one. These two, you can see it. It's just multiply this one by x plus y to get this one. When you get this one, you multiply by x plus y. This is the expansion. What does it reveal? It's very interesting. Notice the expansion of x plus y to the power of n begins with x to the power of n. See, this one, x to the power of 1, x squared, x cubed, x to the power of 4, x to the power of 4, 5. And ends with y to the power of n. This is y to the power of 1, y squared, y cubed, y to the power of 4, y to the power of 5. So that's the first thing we notice. Second, the variables in the terms after x to the power of n, after the first one, they follow this one, x to the power of n minus 1 y. So for example, if you pick this one, okay, as far as the x is concerned, the exponent goes down by 1, becomes 2, and this is 1. In other words, and let me just continue, and I'll show you further on that. And so on to y sub n. With each term, exponent on x decreased by 1 and the exponent on y increased by 1. If you look at this one, first and foremost, let me just, if you can assume that there is a y here with the exponent 0, and notice 2 and 0 must add up to 1, 1 and 1, they add up to 1. 2 and 1, they add up to 1, 1 and 2, they add up to 2 and 1 add up to 3, okay? So this one has exponent 1, they add up to 4. 2 and 2, 4. 3 and 1, 4. This one has exponent 1, they add up to 5. They add up to 5. They add up to 5. This is 1, they add up to 5. So that's important. So in each term, the sum of the exponents on x and y is always n. The coefficient of the expansion follow Pascal triangle. So the binomial coefficient is CNR, n factorial over r factorial times n minus r factorial. So the binomial theorem and the binomial coefficient. And what you are looking at is the Chion triangle. Later on, they also called the Pascal triangle, but it's really Chion. And so you have the combination 0, 0 at top here. In this way, we go 1, 0, 2, 0, 3, 0, and so forth. In this way, we go 1, 1, 2, 2, 3, 3, and so forth. And again, the same thing here. And it's easier to follow it here. You put 1 all the way down. This is a triangular shape. You put 1 all the way down. And then in order to go this way, you add these two numbers, you get 2. You add these two numbers, you get 3. You add these two numbers, you get 3, and so on and so forth. Notice now this is n number 5. What happens to n number 6? This 1 continues. The next one is 1. And then we are going to combine. See, I'm repeating this line. 5 and 10. 5 and 10. 1. So 1 and 5, they add up to 6, 5 and 10 to 15, 10 and 10 to 20, 10 and 5 to 15, 5 and 1 to 6, and the end points, the left and right, are 1. So you keep on 1 here, and the next one you add these 2 and you put it 7, and so forth. Historical note: the triangle was known in China in the early 11th century by the mathematician Jia Xin. From 1010 to 1070. It was also discussed by the Persian poet, astronomer, mathematician Omar Khayyam from 1048 to 1131. The triangle is referred to as Khayyam-Pascal triangle, or simply Khayyam triangle. Now the binomial theorem. For any positive integer n, x plus y to the power of n is x to the power of n. N choose 1, x to the power of n minus 1 y. N choose 2, that means combination x to the power of n minus 2 y2 all the way to y sub y to the power of n. By the way, here you could have n0 class. Let me just put that over here. It's really n0. The reason we may not write it because it's 1. Over here is n, choose n, and that is also equal to 1. Another way of approaching it, if it's x plus some number a, notice this n0 that I mentioned, x to the power of n, then n1, a x to the power of n minus 1, then nj, a to the power of j, x to the power of n minus j, and the last one is nn, a to the power of n. It's important to know the exponents. They must add up. As you can see, these two, they must add up to this exponent. So x plus y to the power of n has this format: summation from r equals 0 to n r x to the power of n minus r y to the power of n. And n r has this format: n factorial over r factorial times n minus r factorial. And again, why am I giving you these useful combination formulas? Because when you want to do the expansion for the binomial theorem, that comes handy. For example, this one is 1, you don't have to worry about it. This one is 1, you don't have to worry about it. Now, this one, n1, this becomes n. You don't have to do it again. And you can, again, you can expand it, you see that. Okay. And what happens is that this, which is 1 to the right of x to the power of n, is the same as this, which is 1 to the left of y to the power of n. And that's this one. Meaning, we are really looking at this. Remember, if these two numbers add up to n, their combination is the same. Number 1 and number n minus 1, if you add them up, you get to n. What does it mean? If I calculate this, I don't have to calculate this anymore. And the same thing for the next one and the next one. And that will speed up the process of this calculation. So we want to look at write the binomial expansion of x plus y to the power of 9. And I've written the synopsis of this binomial distribution, various ways of writing it in this format, in this format, in this format, and those useful formulas that were discussed. So let's do this. The first one is x to the power of n. It's x to the power of n. The next one is n1, 9, 1, x to the power of n minus 1. That means 8 times y. So I'm going to write x to the power of 9 as the first term, according to this. The second one, 9, 1. 9, choose 1, x to the power of 8y. The next one would be 9, 2, x to the power of 7y squared. So right here, you notice we start with n, then it's 8 and 1, it's 7 and 2, the next one would be 6 and 3, 5 and 4, all the way to the n, and 9, 1 becomes 9, 2, 9, 3, 9, 4. So here's the rest of them in the same manner. And again, this one and this one take exponent, take coefficient 1. As I said, this is Cn0, this is Cn. Now, let's expand using the formula. So this is x to the power of 9. This is what? 9 factorial over 1 factorial times 8 factorial x to the power of 8y. We already know this is 9. This one, according to this one, is n. We should know, but I want to show you again. We should know this is 9 because of this formula. And of course, so is this one. But anyways, we write it in this fashion. Let's write this one. 9 factorial divided by 2 factorial times 9 minus 2, 7 factorial, x to the power of 7y squared. Let's do one more. Let's write this one individually. 9 factorial over 3 factorial times 6 factorial x to the power of 6y cubed. In the same manner, the rest of them repeat. Now, we should know this is 9, as I mentioned it. We should know this is 9, and therefore this is 9. But just for the sake of argument, if you look at this one, everybody, and look at this one, I hope you see that they are identical. And what I'm referring to is this. Seven and 2 add up to 9. We are using this property. And it's easy to calculate. So I'm going to calculate that one. I'm going to show you. And the rest of them, I just give you the answer. So we have 9 factorial. So we're going to, let me write the denominator first. So the denominator is 2 factorial, which means 2 times 1 times 7 factorial. So this is 9 times n times 8 times 7 factorial. These two cancel each other. 8 cancels out the 2. 4 times 9 is 36. So which means this number is 36. So is this number. Now, I'm not going to do the rest of them, but I'm going to show you this one is the same as this one. Do you see that? So you don't have to calculate both of them. And this one is the same as this one. So when you go through the process, you get the following, everybody. X to the power of 9 plus 9, x to the power of 8, y all the way to y to the power of 9. Write the binomial expansion of a minus b over 2 to the power of 5. Now, this is slightly different, and I want you to pay attention to two things. Number one, the sign has changed. Number two, this is a fraction, and that's why the way you put it is very important. Conceptual is identical. So if we go with this formula and you want to memorize it with this formula, you say x has been replaced by a, y has been replaced with minus b over 2, and n, of course, is 5. So the first term remains the same. X to the power of n becomes a to the power of 5. And then 5, 1, x to the power of n minus 1 becomes a to the power of 5 minus 1 or 4. Now, y, you have to put it in a parentheses, is negative b over 2. So that's the thing I want to be careful. So one more time. A to the power, so a to the power of 5 plus 5, 1, a to the power of 4 minus b over 2 to the power of 1. Let me just write to the power of 1 so you understand that they have. So for the next one, we get 5, 2a cubed minus b over 2 squared. See, 5, 2a cubed minus b over 2 squared. For the next one, we get 5, 3a squared minus b over 2 to the third. Then 5, 4, a to the power of 1, or simply a minus b over 2 to the power of 4. And finally, minus b over 2 to the power of 5. So this is what we get. So we know this is 5. We know this is 5. If you go back to your notes, we calculated this one in the beginning. You can find it there. And this is the same as this one. Why are they the same? Why are they the same? 5 choose 2, 5 choose 3, 2 and 3, they add up to 5, they must be the same. Okay, so if the bottoms are the same, if the bottoms add up to be n. Just to give you an idea before I move on, just as an example class, let's make something up. If it's 12 here and it's 5 here and it's 12 here, what should be here? What goes in here has to be 7. Why? Because 12 minus 5 is 7. So they're identical. So this is a to the power of 5, as I mentioned. This is 5, a to the power of 4, minus b over 2. Here's the third one. As I said, this is 10 a cubed minus b over 2 to the power of 2. And then this repeats to be 10. This repeats to be 5. And why do we keep this in a parentheses? Because now it makes a huge difference, now the signage. So this is a to the power of 5. This is minus 5 halves a to the power of 4b. This one is with this negative sign. Well, this is b squared over 4. So this is 10 over 4, which means 5 halves a cubed b squared. And it's positive because this is being squared. Minus b cubed over 8. So plus 10 over 8 becomes plus 5 over 4. Negative makes it negative 5 over 4. A squared b cubed. This one to the power of 4 becomes b to the power of 4 over 16, which makes this 5 over 16 a b to the power of 4. And when you raise this to the power of 5, becomes minus b to the power of 5 over 32, or minus 1 over 32, b to the power of 5. Be very careful. When a case like this happens, you must put it in parentheses to figure things out. Find the fourth term of a plus 2b to the power of 10. Well, there are a couple of ways to approach it. I'm going to quickly show you. The rth term of the binomial expansion, given x plus y to the power of n, is summation of I going from 0 to an n, I x to the power of n minus I y to the power of y. Please understand this can be I, this can be R, whatever you want it to be. The reason I chose I here because I want to explain the rth term. The rth term of a binomial expansion is x plus y to the power of n, where n is larger than r minus 1. And in that case becomes combination of r, choose r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. If you look at the expansions that we have seen, it predicts that, which is different than saying, what is the term that contains x to the power of j? In that case becomes combination of n over n minus j, x to the power of j, y to the power of n minus j. So if we stick with that, let's see what happens. If we stick with that, first of all, n is 10. We want fourth term. If we stick with that, r is 4. And of course, x is a, y is 2b. So this part is, obvious. N is obvious. We want the fourth term, and we want to stick with this formula. I'm going to stick with this formula. So replace everything. So n is replaced with 10, r minus 1, 4 minus 1, and just plug in. Instead of x, a, instead of y, 2b. So we put 10, 4 minus 1 here. X is a, so a to the power of 10 minus 4 minus 1, 2b to the power of 4 minus 1. And this is fine. We will finish it in a moment. But before we do that, here's the second method. Is, as you recall, we use this methodology, class. Just remember, we said that this is the n factorial. If you use this one, divide by r factorial, n minus r factorial, x to the power of n minus r, y to the power of r. And the type. All right, so what happens next? If we go with this one, notice for the first term, R is 0. For the second term, R is 1. For the third term, R is 2. For the fourth term, R is 3. I hope you remember that for the first term, we have 10, 0. Do you remember that? So the very first term, this becomes 10, 0. That's what we are referring to R. 10, 0, 10, 1, 10, 2, 10, 3, 10, 4, and so on and so forth. Fourth term, R equals 3, so it's 10, 3. 10, 3. A to the power of 10 minus R, 10 minus 3, or 7. Notice this number is 3, this number is 3, this number is 3. And we are saying by looking at this, we can recognize the same thing. And I have no idea which one is easier. So 10 choose 3, 10 choose 3, a to the power of 7, 2b to the power of 3. And again, it's important to know that you have two ways. You can stick with this methodology or completely ignore it, go back to what we just discussed and figure out with the fourth term, it means R equals 3. That may be easy. You don't need to memorize any formula. So combination of 10 choose 3, just this part is 10 factorial, 3 factorial, times 7 factorial. You choose this one, this is 10 times 9 times 8 times 7 factorial. Then you do the math here and you end up with 120, 8 to the power of 7. This is 8b cubed, and we get 120 times 8, 960, 8 to the power of 7, b cubed. Again, please understand this. If it was a plus b, would have been, of course, is much easier. But on purpose, this is something different, and it may even be negative, so you have to figure out what happens. There is a third method, and the third method is just expand this. Imagine they didn't ask you for the fourth term. They said expand this. So expand it, and then 1, 2, 3, fourth term. The difference is if you know the concept here, of course, it's a lot easier. Example 9, use the binomial theorem to expand 3y plus 2 to the power of 4. One more example. So this is 4, 0, 3y to the power of 4, then 4, 1, 3y in a parenthesis to the power of 3 times 2, 4, 2, 3y to the power of 2, 2 squared, and so forth. So this is the expansion. And we already know the following, everybody. We know this is 1, this is 1, this is 4, which makes this one 4, just for the sake of argument, okay? But in any event, I'm going to remind you that these two are equal. So 4, 1, and 4, 3 are equal, okay? And then we do 4, 2, and 4, 2 is 4 factorial over 2 factorial times 4 minus 2 factorial, which is this. 2 factorial is 2 class, okay? So this is simply 4 times 3 times 2 factorial, and then 12 divided by 2 is 6. So we have everything we want. We plug in, we replace. As I said, this one, the only thing that you want to replace is this one. The rest of them are very straightforward. So 3y to the power of 4 is 81y to the power of 4. That's why you put it in a parenthesis. One common mistake is that students just put, here's what sometimes students do, please avoid doing that. They just write they just write 3 and then y to the power of 4, and that will be a mistake because they don't raise number 3 to the power. All right, so as I was mentioning, the mistake that happens sometimes, students write here, they just write this, which is not the same as this. Notice, in this case, only y is being raised to the power of 4, whereas here, 3 to the power of 4 gives you 81, y to the power of 4. So you want to be careful with that. And then we multiply them through 4 times 2 times 27, 6 times 4 times 9, 4 times 8 times 3y, and so forth, because this one is 3y cubed. 3 cubed gives you 27. This is 3y squared. 3 squared gives you 9. 3 squared, 2 squared gives you 4. That's the 4 here. And then 3y is here. 2 cubed is 8. And if you put them all together, this is the final answer. 3y plus 2 to the power of 4 becomes 81y to the power of 4 plus 216y cubed plus 216y squared plus 96y plus 16 as the final answer. Let me just quickly share with you this one also. We want to find the 7th term. Okay. And we have two choices. We can go with the formula that I mentioned here. N is 8, R is 7. If we stick with x plus y, so x is being replaced by y and y is being replaced by 3. And if we go with this formula, okay, we replace the n with 8, r minus 1, 7 minus 1, and we write the rest of it. So 8, 7 minus 1, y to the power of 8 minus 7 minus 1, and so forth. Or the second method that I mentioned is that we know this is the case. Y plus 3 to the power of 8 is the summation of r from 0 to 8 factorial over r factorial, 8 minus r, close parenthesis, factorial, y to the power of 8 minus r, 3 to the power of 1. So we want the 7th term, and we may notice that the first term, remember this is 80. If you write it down, this is 80, everybody, for the first term. So for the first term, r is 0. Second term, r is 1. Third term, r is 2. So as you go through the 7th term, r must be 6. So you can go with that. Either way, this ends up being 6. That's the idea. So you don't have to memorize this formula. You can just go with what we have. And so combination of 8, choose 6. Y to the power of 8 minus 6. 3 to the power of 6. And you write 8 factorial over 6 factorial times 2 factorial. This is 8 times 7 times 6 factorial. These two cancel each other, and this cancels out. This one gives you 4. And now when you do the math, their product becomes, with 729, becomes 20,412 y squared as the final answer.